hybrid energy system, and then we will be discussing how we will be optimizing hybrid energy system, and then in the last we will be discussing what are the effects of using various forecasted data of weather parameters and what are the effect of that data on the hybrid energy system optimization result. So I will be as you all are going from renewable energy system from last few days, you have learned a lot about renewable energy systems and how they will be useful. What are the importance of the high renewable energy sources? So I will be not going in detail about these, but I will be briefly want to introduce these because they will be the integral part of the hybrid energy system. And before going to hybrid energy system, we have to understand individual renewable energy source, and then we will be able to optimize, because for optimization of anything or before going to in deep for any type of the system, we must understand the basic philosophies of the various parameters. So first we will be going for renewable energy system. So as very you all have know that renewable energy is the kind of energy that we will be collecting from the renewable resources which are naturally available to us on a human time scale, and they are not exhaustive. They will be not going to be die out after some time, and with the help of these we will be generating the electrical energy. And generally the resources which we will be using will include sunlight, wind, rain, that is in the form of water, tidal energy, wave energy, and the heat which is available in the geothermal. Generally, we will be going through various terms which are coming in electrical engineering. We have clean sources of energy. We have some sources that are known as renewable sources of energy. And then sometimes the terms come is non-conventional sources of energy. So generally we are interpreting these terms as same, but because there are some difference between these sources, so we will be briefly discussing when we are talking about clean source of energy. So all the sources which does not harm the environment will be coming under the clean sources of energy. And the renewable energy sources which use the source which is capable of renewable, which will be again and again can be used without affecting on that parameter. And then we have non-conventional sources of energy. So the non-conventional are the sources which are not available in the traditional time, and they are new sources of energy which we will be using for generating the energy. So first source of energy which we will be using is the wind energy. So wind energy, as we all know, is the energy which we will be using and converting the heat. So wind energy, wind speed, and with the help of that we will be using a turbine or shafts which will be converting and rotating with the help of this wind speed, and then that will be converted as the electrical energy with the help of generators. So as we all know that wind is the movement of air which is caused by the uneven heating of the earth's surface. So as you are aware that wind is all available everywhere, and we will be using wind turbines that they have blades and which will rotate with the help of wind, and that will produce the electricity with the help of generators. So the major advantage which are associated with wind energy is because wind is freely available. It does not cause the greenhouse gases or other pollutant to be transferred in the environment. Although wind turbine can be very tall, they only take up a small plot of land because they are vertically constructed and they require very less example less land for construction. They are not used horizontal surface, and the land below that can also be used for various other purposes that can be for agriculture also. And wind farms are appealing to the landscape. They will be giving a beautiful structure to the land also, and it can be easily used in the remote areas where the other source of energy is not available. When we are talking about various disadvantages which are associated with wind energy, the amount of wind available will be always vary, and there will be time when there is no wind available or very less or very high amount of wind available, and at that time the wind turbine will not be generating any kind of energy. And wind can turbines can be noisy because when they rotate they will be causing a noise, and because the wind turbine has to be anchored to the ground, this could be possibly impact the soil structure of the system, and they do not produce the enough electricity to power large amount of houses, and birds and bats are threatened by these turbines. Generally, we are having two types of wind turbines. One is horizontal axis wind turbine, and then nowadays there comes second type of wind turbine, that is vertical axis wind turbine. In horizontal axis wind turbine, the wind turbine blades are rotating in the air, but in vertical axis wind turbine the rotation will be round the turbine shaft, main shaft, and it will be very simple and accessible, and it will reduce the operating and maintenance cost of the system. Nowadays, the new concept of generation of electricity with the help of wind turbine has been come, that is wind trees. So we will be using a very small kind of wind turbines, and they will be connected in a shape of wind tree, and then with the help of that tree we will be generating electricity with this help of these small turbines. So example is we have a 30 feet tall and 23 feet wide, total 54 leaves turbine that can capture up to 5.4 kilowatt of energy. So a very small 30 feet by 23 feet tree can generate 5.4 kilowatt of energy at any time, and it can produce around 2400 kilowatt hour annually with the help of these wind turbines. And these trees will also be used as a beautification purpose for the land, and it will not be looking very bad when we are looking from the point of view. So these trees can be installed anywhere without requirement of much space. And then, because as you all are aware that we have blades which are rotating, but now there are research going on and there are some wind turbines which are bladeless. They did not have any blades in it. They will turn the entirely away from the blades, sinking instead to harvest energy through the air flow induced vibration of the mechanical system. So we will be using the vibration mechanism. The air will be causing the vibrations in the system, and then we will be converting that vibrations into the energy. So then second kind of energy can be hydrogen energy, because hydrogen energy does not require, generally it comes in all kind of energy sources. They comes in conventional source of energy also. They will be also coming under non-conventional source of energy, because they does not require, or they are also renewable, because the water is not actually used. Only the wind speed of the wind is, sorry, water is used for converting that into kinetic energy, into electrical energy. So generally hydropower is the force of moving water, and that is mainly due to the gravitational force. And a very small hydropower plants can be constructed. So this is an example of very small type of hydropower plants which does not require a large construction. It will be having a very small turbine shaft which will be used, and then that with the help of that turbine shaft we will be rotating the generator to generate the electricity. Then the major source of energy which we will be focusing on is the solar energy. Solar energy is the radiant energy available with from the sun, and that energy will travel from the sun to earth. And solar energy is produced in the sun core, and the atoms of the hydrogen combines under the pressure to produce helium gas, and they will produce a fusion, and then radiant energy will be eliminated from the system. So we can capture this solar energy with help of solar collectors, which turns the radiant energy into the thermal energy, or with the help of photovoltaic cell that turns the radiant energy into the electrical energy. The major advantage which are associated with solar is we have renewable, produce no pollution or no waste in the system. If the area is sunny, the solar energy can be used in the remote areas where no other energy source will be available. It requires very little maintenance, and because it is expensive in beginning, we can save lot of energy in long terms, because it will reduce the energy generation cost in a long run. The major disadvantage which we associated with the solar energy, because we know that solar energy or sun is not available in the night, so the solar panels will not be working during the night time, and solar cells and solar panels are very expensive, can be unreliable unless we have a very sunny climate, and solar power agent must be used for higher power application, because they will be using solar cells which will be only available very small amount, so decent amount of power can be generated with the help of solar panels. So the solar energy which will be coming, we are only using a very small amount of solar energy which will be coming. So you can see from this that we have 174 picowatt of energy which will be coming from the sun, and only 1 to 2% of that energy we will be able to use, because majority of the power which will be generated will be absorbed by the land and ocean area, and that is also absorbed by the atmosphere, and very small amount is only available to be used. and approximately 30% is reflected back to the space, while the rest is absorbed by the clouds, oceans, and land masses. By photosynthesis, green plants will convert the solar energy. So, solar energy is the third largest renewable energy source after hydropower and wind. Because wind turbine can be constructed in large size, there are very limited number of wind farms available, but because of their capacity individual farm can have, they are generating large amount of energy as compared to the solar. So hydropower is the number one source, wind power is the second, and solar power is the third largest source of energy which we can, renewable energy which we can use. The sunlight will strike the earth is more than 10,000 times the world total energy used. So you can think of, if we are able to convert only 10% of this energy which is available from the sunlight, it will be 1%, it will be sufficient to be generate the total electrical energy which is required by the total world. So when we are talking about the history, I will be not going in detail. We are working in the third generation of solar cells, and these are the various solar cells which have efficiency, because the efficiency of the solar cell is the major issue which we will be facing, because the solar cells will be having very low efficiency. Nowadays, the commercial solar cells which are available in the market will be having around 20% efficiency of the solar PV. That is 20% energy we will be getting from the solar radiation will be converted in the form of electrical energy with the help of solar cells. But now we have many researchers which we are working, and there are some of the sources which are available, which are coming, which will be having the efficiency of around 40 to 45%. The first generation is the single junction silicon cells, which will be used around 80% of the solar cells which we will be using, and single crystal silicon cell will be having efficiency of 16 to 25%, and multi crystal silicon will be having efficiency of 14 to 80%. Then comes the second generation, that is thin film cell. The efficiency of these are less as compared to the single. It will be having efficiency around 10 to 11%, and they will be known as the second generation, and they will be using cadmium, copper, indium, and then now we have multi-junction cells, that is third generation cell. So the third generation technology will aim to enhance the poor electrical performance of the second generation, because they will be having a very less efficiency. So the current research which is targeting a conversion efficiency of 30% to 60% as compared to 15% to 20% of the cell. So we have multi-junction cells which will be having 30% efficiency, and we are working on it for getting 40 to 43% efficiency. So the current and upcoming innovative materials which we will be using a crystalline silicon, thin films, and perovskite solar cells. So the silicon cells, we have photovoltaic solar cells, we have silicon based solar cells, and now some are dye sensitized, or that is also known as nano solar cells. Now, because we have solar cells, so because it requires horizontal area for the constructions, so now we have researchers which are working to use it as a floating solar farms which will be installed in river or lakes, and they will be producing the electricity. It does not require any land, and also they will be used for saving of water evaporation which will be taking place due to the heat energy of the sun. So silicon panels are becoming cheaper and more efficient day by day. So for photovoltaics are the photovoltaic solar power systems which will be created from floatings on reservoirs, dams and water bodies without using valuable land or real estates. They can generate the electricity. Their installation cost is also less because they does not require any installation on the land which require a separate arrangement for the installation on the land which he will be having MPPT system, and the power produced is greater by up to 10% due to the cooling effect of the water, because the water is in under the solar cells. The solar cell will be continuously very fast cool, and then with the help of solar it will be generating more energy as compared to the land solar panels. Now the second technology which is coming up in the market is the BIPV solar technology. That is, it will be seamlessly blended into the building architecture, and they will be used to form the roofs of the house, canopies, curtain walls, skylight systems. They will increase the energy efficiency of the house, and they are highly thermal, and sound isolations will be also provided by these cells. Clean and free power output from the sun. They have very less operating and maintenance cost. And then now comes the solar skins. So they will be used as the part of the your house roofs, which will be looking like the part of the house, but they will be solar panels which will be generating the electricity. And solar skills are the novel PV technology to integrate the custom design into the solar panel system. These imprinted custom images will embedded into the solar panel and beneficial for businesses and government offices. They can be customized to display the logos, advertisement, country flag, and so on. So they can be used for the advertising purpose also, and they will be as for advertising as well as they will generate the electricity. Now we have one more advantage which have associated with the solar photovoltaic cells. They can be work as a noise barrier or isolators. So nowadays we have a highway traffic noise which is a very area of concern. So the solar panels which are installed alongside the highways will be working as the noise barriers, were or which will be a single aim for design cost effective barriers that will be efficiently perform noise absorption, and they will be also generating the electricity. So these are the some sources of energy, renewable sources of energy which we will be using. But the major disadvantage which are associated with them is they have limited generation capacity, and they depends on the weather parameters of that location, and they are not always available in the system. And due to that, there comes the requirement of hybrid energy system. This will be basically a renewable source of energy system which will be using more than one kind of source, and they will be used to generate the electricity. And a typical example is shown. We have three types of generation of electricity in the given diagram. We have PV panels, which will be converting the solar energy into electrical energy. Then we have wind turbines, which will be using or converting the wind energy into the electrical energy. And then we will be having a diesel generators, or it will can be a hydro generators, which will be generating the electricity. And with the help of these, we will be generating the electricity. And in the hybrid energy system, we will be using the storage of the system, which will be converting or storing the excess energy which will be generated by the system, and then they will be used when there is less energy available in the system. So a hybrid energy system will consist of two or more energy sources which will be used together to provide increased system efficiency and as well as greater balance in the energy supply. Because as you are aware, if we are having only solar panels, so solar panel will be not giving any energy in the night, and if there is the cloudy atmosphere, then also they will be not be producing the energy. So if we are using single source of energy, it will be issue for us. So we will be not using single source of energy. We will be combining two or more renewable energy sources. So we have one question which is coming. Are floating solar energy systems safe for aquatic animals and fishes, as it can decrease the infusion of oxygen? So solar floating panels are not covered complete part of the land, sorry, water bodies. It will be only a small part of water bodies which will be used, and or oxygen or other things will be with the help of, it will not cover 100% of the water bodies, so it will be not be a very large issue, and that will be also not 100% touch on the water bodies. There will be a gap between the water and the solar panel which we will be connecting, and with help of that there is no issue of these. There are some concern, but there is no large amount of concern which are associated with it, because there is a gap also, and it will not 100% covered by this system. So in hybrid energy system, we combine two or more renewable energy sources, but it will be depending on the natural local potential of the user, because we have to consider what are the weather parameters of that place where we want to install this renewable energy system, hybrid energy system. So we have to first analyze the local potential, and on the basis of that local potential, we have to design our hybrid energy system. And there comes the role of engineers who will be designing, because it is not always advisable to generate very large amount of energy which will be going west, and it is not also suitable that we will be having the system which will be generating less energy as compared to the requirement. So we will be combining the two or more renewable energy sources based on the natural local potential of the users, because they are low cost, modular and quick to install. They are, because fuel is abundant, it will be very economical to use, because they are free and inexhaustible, the sources which we are using for converting the or generating the energy. The environmental protection, especially in terms of CO2 emission, is reduced drastically. And because now we are all are working towards generating zero carbon economy or zero carbon energy production, the hybrid energy system will be a very useful technology which will be using to generate the electricity, because they does not produce any amount of CO2 gas. They have diversity and security of the supply, because we have designed a system based on the local potential and local user requirements. So it will be secure system. It will be generating the supply as per the requirement of the local system. Then, because we have designed the system with the help of various algorithms, we can predict the cost which will be required for generating the electricity, and it is not influenced by the price fluctuation which will be nowadays taking place very rapidly. Wind energy and solar energy can be competitive with nuclear, coal and gas, especially considering the future cost trends of these coal, gas and nuclear materials. So wind energy and solar energy are the most competitive form of energy which can be used for generating the electricity and supplying it to the consumers. And one more advantage which is associated with hybrid energy system is that it can be used for remote area applications where we don't have any kind of energy which is available, and it is not necessary that we will be using a grid connected system. We can construct a standalone system which will be used. And now we have research which is going on in the storage area also. So we have storage systems which will be used for generation of electricity, storing of electricity, and very economical way. So nowadays fuel cells, hydrogen cells are coming up, which will be having a high capacity, and also they can be used for the other applications as per the requirement. So the major challenge which is associated when we are talking about hybrid energy system, the most important term is that the system which we are designing must be able to supply the load at all times. So this is the major challenge which is associated with any kind of energy system, because we have designed the system according to the user requirement, and the load of the user must be completely satisfied. It must be able to supply the peak load. It must be able to supply the off peak load also. So the major challenge is that the system which we are designing must have generation which is equal or more than the load requirement of the system. So the all generating assets will have unique operating constraints, and they have their own advantage and disadvantages. So as we know that renewable resources are intermittent, fossil fuels are expensive, and it will cause environmental pollution. The optimal generation may only be in a narrow operating range, because when we are designing a system for a particular load capacity, it will be sufficient to generate the electricity. But when we are talking about a large range, it not be optimal generation, it cost may be high. Each assets will have typically have different power characteristic. So when we are using them combined, we have to provide a system that will accommodate the different power characteristics, and it will be able to supply the load, particular load, which is a single unity. The next big challenge which is associated is load is inherently variable. So when we are talking about any load, it is not always fixed. It will be user dependent. So whenever we are going for design any system, if we have a constant target, it is very easy to design the system. But when we have a moving target, it is very difficult to target. So the next challenge, which is when we are talking about hybrid energy system, because we are designing the system on the basis of the user requirement, and the user requirement is moving, we have to design the system with this moving target. The next challenge which is associated with hybrid energy system or any kind of renewable energy system is it is site dependence of the renewable source. So it is not easy to have any simple fit to all philosophy. We have to design according to the customer requirements and location centric. So one system which we design for any location, that system is not applicable to all places. So according to the site location, we have to design the system. So it is not a fit to all solution. We have to design a system which will be dependent on the site, because site survey with long-term data acquisition and forecasting is required before designing a renewable hybrid energy system. Then hybrid renewable energy system design, we focus or we want to design a configuration and size of the hybrid system components with the objective that it will be supplying the power reliably under the various atmospheric conditions. So because the atmospheric conditions are varying, we have to design a system which will be able to supply the power reliably. That means there must be no load which is not supplied by the system, and there also must be no time when energy which is generated is not utilized by the system at all. So this is the major objective, main objective of the hybrid energy system design, that we have to supply the power reliably. Then we require that when we design the system, the total cost of the system must be minimum. And then we want to maximize the efficiency of the system with the help of efficient energy flow and management strategies of the system. So these are the major objectives which we want to achieve when we are talking about hybrid energy system optimization. So when hybrid energy system optimization has to be done, we have to identify what are the various size of the components which we want to install in this system. What is the configuration we will be using, what kind of sources we want to require, and what will be the operating strategy for that system. And on the basis of that, we want to achieve that your supply will be completely reliable, cost of generation must be minimum, and the maximum system efficiency must be there. So the challenges which we have discussed, we can summarize that we have highly variable resources available. It is not we have a system which is giving a constant energy, and we can easily design a system which will be able to supply the load as per the requirement. Because our system are dependent on the nature, so they are highly variable resources, Like we cannot identify or analyze what is the wind energy which will be available at any time, what will be the sun energy which will be available, sun will be available or not during that day. So the design must incorporate all these parameters in the system design. Then we have many components which are connected in the system. They are individual components, they are very good, but when they are combined, their efficiency and other parameters performance can be reduced. So we have to design a system according to the requirement of the system. Then we hybrid system have a 65% or more failure rate. So generally the hybrid energy system which we will be designing, it will be having a 65% or more failure rate. And this failure can be due to various issues. It can be due to the component failure. It can be due to the availability of the resources. It can be due to the poor maintenance of the system because the component require regular maintenance, etc. There will be a lack of monitoring of the system. We always require the history logging of the system because we have to design the system which require a large amount of data of the weather parameters, load, etc. when we are designing. So we have a large amount of data which we have to analyze. When then we have a remote location, so we have to accommodate the remote communication system in the system. The economical viability of the system must be analyzed, and the cost of the generation of electricity and total cost of the system must be economical so that we can use. And a cost benefit analysis of the hybrid system must be done for a reasonable payback period. That means we have to design a system which have a reasonable payback period. That is, it will be giving us 5 years or 10 years the cost which we have connected. It must not be a system which will be requiring 25-30 years to give us back the money which we have inserted in the system. So a cost benefit analysis of the system must be done in the designing of the hybrid energy system. So individual integration of each assets type is generally well understood by the technical community because we are understanding individual component. So we have understand how they will be behaving when they are integrated together. There are some power quality challenges which are associated with the system. So we have to incorporate that also, that is frequency and voltage control of the system, VAR control of the system. If we have designed a grid connected system, then stability of the system, flicker, harmonics of the system must be incorporated. And challenges increase disproportionately when multiple assets are combined. So because whenever we are combining more and more kind of sources, challenges which are associated with them are reduced. Because when we are using a solar system, we have a issue of availability of solar. But when we are using solar wind combined, generally whenever there is a solar, there is less wind availability, or it may be when we have a wind availability at night which can accommodate the system requirement. But when we are adding one another source, we have more flexibility which is available to us. So it will be decreasing the challenges in terms of some parameters, but it will be also increasing with the issues. So we have to implement a dispatch strategy also, how the system will be used, how the energy will be supplied, which engine will be turned off and which engine will be turned on, and who will be doing the on-off work of the engines, how is the engine is optimally running, how do you keep engine at optimal speed when the load is varying, because when load varies your system requirement change, and on the basis of that the system speed will also increase or decrease, and on the but we require that our system must be running on optimal speed. What do you do if the load suddenly drops sharply? Because in some condition there is a sudden drastic load of the system, and what we will be doing in that condition? What do you do when you have excess power generation in the system? Because the whole load has been supplied, but your system is still generating the electricity. What you will do with this excess electricity which is generated by the system? How do you control the peak saving of the system? Because at the time of peak load, peak generation of electricity, we have a, it may be possibility that when we have a peak generation, there is less user requirement. When we have a peak requirement, there is less generation. And how that can be used, and we can use reduce the peak cost energy at that time we have to accommodate. So these we have discussed in detail, what are the merits, advantage and disadvantage which are associated with the system. So I will be skipping. So as we have discussed that we can have a hybrid energy system. Hybrid energy system can be a on-grid system or it can be a off-grid system also. So we have to understand the system, how we will be using. I will be mainly focusing on off-grid system that can be easily converted with one more kind of source, that can be a grid supply. So whenever there is a difference which can be used, but I will be focusing on off-grid energy system. So off-grid hybrid energy system, it will be generated by a single source system, or it can be generated by combining two or more type of the sources. Energy storage is a necessary requirement when we are talking for a off-grid electricity system, because energy storage in the form of batteries, and that can be used to supply the power to the AC or DC load or both. It may require AC, it may require DC or both type of electric buses as per the requirement. If the load is only AC, then only AC buses are required. If we have both type of system, we require both. The system can be only DC depend also. So it will be that. We require power conversion devices because we have some sources which are generating AC, some sources which are generating DC. We have load that can be AC, or we have load that can be DC. So we require both kind of supply which will be required, and we have both kind of sources. So we require power conversion devices like inverters and converters which will be converting AC to DC and DC to AC. Components or system control or both is used to regulate the overall system operation of the off-grid system. So we have discussed about hybrid energy system, what are the various challenges which we are associated with the system, and then what we want from the hybrid energy system. So now we will be focusing on the optimization part of the hybrid energy system. So as we have discussed, we have to optimize the system for size, for the configuration. So we will be having a optimization problem. So we have optimization problem that will be based on the cost of the component which we are using. It will be, if we have a fuel requirement, then the fuel, then labor cost which are associated when we are having operate components or energy sources available for maintenance and running, and if we have a transportation and maintenance cost which is associated with them. And our main aim of hybrid energy system optimization is to evaluate the most cost effective dimensioning of all components and their operational strategies. So this is the major design problem which is associated with hybrid energy system. We want to design minimum cost of the system by designing the size of the various component, and then how that system will be operating, that also has to be designed. So the problem associated is design and investigation of hybrid energy system optimization algorithm for the sizing and operation control. So the problem is we have to design and we have to use any optimization algorithm for sizing of the hybrid system. The design optimization problem, optimization methods which we will be using will be dependent on the resources availability, that will be wind speed and solar radiation data for past years we require when we have to design a system. We have meteorological data of previous years, but they have variations when we are comparing it with the present value. So as you know that today's weather will be different from tomorrow's weather, and when we are designing a system with the help of today's weather, it may be possibility that that system will not be effective for tomorrow's weather. So we have optimization problem, we have optimization of hybrid energy system. So basis of all these terms, we can easily say that it is a very complex optimization problem, because we have many issues which we have to handle, and then we have a non-linear system, because we cannot predict what will be going to happen, and all the parameters which we are dealing, like wind speed, solar radiation, load, they are fluctuating in nature, they are variable, and they are not linearly varying, they are non-linear nature. So a hybrid energy system optimization problem is a very complex problem, and it is a non-linear problem with multiple variables. So we require a algorithm. I have designed a BBO algorithm for the optimization of the system. The wind speed and solar radiation have random variation in them. So result will be showing that the performance of the hybrid energy system can be improved with better decision making support when we are using data of forecasted weather as compared to the previous weather. So I will be using a case study for understanding the system. So in that study, we will be using a solar PV panel as one of the component, wind turbine as second component, pico hydropower plants, which is very small capacity hydropower plant, and then we have a diesel generator, And these are the 4 types of energy generating system which we will be using in this hybrid energy system. And then we will be having a battery energy storage to store the energy when the excess energy is generated and use it when we have a deficient energy generation by the system. Then we can have inverters and we can have battery chargers, because the solar panels will be generating a DC energy, and the wind turbine, pico hydropower plants, diesel generators, they all will be generating AC supply. Energy storage will be in the form of batteries that also require DC supply. So we require a battery charger, that is converter, and then we require an inverter which will be converting this DC supply to the AC supply whenever required. So these are the various systems which we will be using for understanding the system. So now the operating methodology, how we will be operating. So operating will depend on what is the cost of energy generation by the individual components. It can be easily understood that the solar PV panel energy generation will be economical as compared to the wind turbine generation. So when we are talking for this kind of philosophy of how we will be operating, first the hydro power plant will be turned on whenever there is a requirement to supply the electricity. So pico hydro, on the basis of availability of the water, first it will be supplied the energy to the load, and if the hydropower plant is not capable to supply the load, then we will be using the wind turbine for generating the electricity, and these two will be supplying the load requirement. If these two are also not able to supply the load, we will be using solar PV panel for supplying the electricity. And if these three are also not able to supply the load, we will be using the battery. And if these four is unable to supply the load, then only we will be using the diesel generator. So the diesel generator is the last source of energy which we will be used if all other methods of energy generation is not able to supply the requirement. So when we are talking about a hybrid energy system design, these are the mathematical formulas which we will be used. We first require to calculate the net present cost of the system. Then we have to calculate cost of the energy which will be generated. So it will be the total energy generated by the system divided by the total cost of the system annual. Then we have various components which we will be using. Each component will be having their own mathematical calculation for calculating the cost. We have power requirement, then it will be having a operating and maintenance cost. It will be also having a replacement cost. There will be a total number of years it can be used, and there also the cost which is associated, that is interest rate for the system. Then individual component which we will be using require a mathematical formula when we have to analyze the system. So photovoltaic panel, what will be the power output of the system? It has to be designed. And then we have wind turbine which will be requiring to model. Then we have a hydropower plant which required to be designed, and then battery system has to be designed. I will be not going in deep what are the mathematical formulas for this. So the optimization of hybrid energy system, with 1 minute. So when we are talking about hybrid energy system, we have to design a system. We have various algorithms, and on the basis of that algorithm, we have to optimize the hybrid energy system. So this is a typical algorithm for optimization of hybrid energy system. So first we have to select which algorithm we have to use. It is your choice which algorithm you want to use. There are lot many algorithms which are available. You can use GA, you can use PSO, you can BBO, you can use ACB. You can nowadays more and more algorithms are coming up which you can use. So first we have to analyze which algorithm we want to use, and then on the basis of that algorithm we have to initialize the algorithm parameters. Then we require to input the system with various input parameters that will be like weather parameters, demand, that is load, what are the costs associated with the various components, what are the various system parameters, what are the various economical factors associated with the system. And then we have to design a object which we want to optimize. So the object which we want to optimize will consist of system configuration and the component size. So what are the various system components which we will be using, and what are the size of that? That will become one objective function in the optimization. Then we have to give some constraints which we want to apply. And when we have given these, we have two stages of optimization algorithm. First stage will be main algorithm, which will be calculating the objective function value, that is the system configuration and initial cost. And then we have to design what is the total cost of energy of that system. And then we have to a sub algorithm which will be analyzing the designed main algorithm objective function, that it will be performance is reliable or not. And then we have to design that algorithm for the complete lifetime of the project, and this algorithm will be continued till we get the optimal result. And if the optimal result is reached, we will be getting the system. So the optimization problem of hybrid energy system, as we have discussed, is to minimize the cost associated with the hybrid energy system. So the objective function is minimize the total cost of the system. The cost of the system will be cost associated with the various components. There are some constraints on the optimization system also, like there will be always a specified number of components which can be used. So there will be always a limited number of PV panel available, we have limited number of batteries available, we have limited number of power generating by the wind turbine. So there may be a constraint which is associated that the battery power must be within the range. It cannot be used 100%, it cannot be used zero, it cannot be used 100%, or it cannot be charged beyond 100%. So there are many constraints which are associated with this hybrid energy system optimization. So the optimization algorithm, as we all are aware, we have to initialize, we have to evaluate the objective object which we have initialized. If that is able to supply, we have to check that this is sufficient to supply the process. If it is convergence, that means it is minimum cost, then we get the optimal output. Else we have to do the modification as per the algorithm, and this evaluation has to be complete again and again done. So it is a animation of how the optimization is working. We will be having various objectives which we will be using, and we will be allocating them in the search space, and we have to do the optimization algorithm, and on the basis of that optimization algorithm we will be modifying the objects, location of the objects. They will be going towards the final solution, and there will be a possibility that they will be local minima or local maxima, but we have to reach to global minima and global maxima. So there will be a methodology in the algorithm to counter that issue. So this will be like this, and then finally all will be convergent toward the final solution. This will be the basic philosophy which we will be using in any of the optimization algorithm which we use. As we have discussed, there are lot of the optimization algorithm available. So we have sizing methodologies that can be having a classical optimization methods like linear programming, graphical method, analytical method. Nowadays we have many artificial intelligence algorithms which are coming up. So we can have single artificial intelligence method which are available, that can be classical and that can be modern optimization algorithm. Here are some of the algorithms that are classical like CQ search, object oriented programming, fruit fly, gravitational search, mine blast, breach storm, cow search. And then now we have many modern optimization algorithms also available like genetic algorithm, particle swarm optimization, harmonic ant colony, bacteria foraging, etc. And then nowadays more trends is coming to combine one or more optimization algorithm to design a hybrid artificial intelligence algorithm. So this will be combining two or more optimization algorithm in one algorithm, and it will be using the benefit of all the optimization algorithm. Then there are some computational tools are also available which can be used for hybrid energy system optimization. The most commonly used optimization algorithm is Homer software. 80 to 90% of the research in hybrid energy system optimization is done with the help of Homer. So if you search hybrid energy system optimization, you almost get 80% of the paper which will be using Homer as the software tool for optimization of the hybrid energy system. And because it is location dependent, parameter load dependent, so we have Homer algorithm which will be accommodating this, and it will be giving you the result. There are many more algorithm software tools which are available, that is iHogo, Transcript, RAT, Screen, MATLAB, Hybrid, RRead, Leap, VPower. These are the software tools which are available for designing of the hybrid energy system. BBO algorithm I will be not going in detail because of the time constraints. These are the algorithm which we have discussed. We will generate a particle. We have to check the feasibility of that particle, that it is feasible to supply the load, because it must be within the search space which will be allocated to us. Then we have to, using cost function, we have to calculate the net present cost of all the particles which we have generated. Then we have to calculate the lambda and mu based on the fitness value of the system. We have to apply the convergence formula. If we have converged the result, we have to stop, else we will be selecting the habitats on the basis of mu. Then we will be performing the migration operation, and then we have to select the habitat or particle on the for mutation operation, and then we have to again check the feasibility of that component configuration, and then using the cost function we have to again calculate the net present cost. Then we have to sort the population, and then we will be doing the elitism operation. That will be, we will be only having top solution and we will be discarding the bottom solutions in the system. The input which we have discussed in detail, weather parameters, load, demand, component size, etc. Then we require the output by the algorithm as over of operation, total fuel requirement, what are the output of the various components, what are the various cost and various graph which we require. So here I have presented a optimization algorithm results which will be consisting of PV, wind, diesel generator, battery, inverter, and the net present cost that has been calculated, and the total energy which is generated by the system, and then we have cost of energy which is there. So the optimal result based on the various algorithms has been compared, and Homer software also it is compared. These are the various graphs which we will be getting with the help of this. What is the load demand, what is the total PV power generated by the system throughout the year. Here I have only shown for a small duration of 7 days. Then what is the wind power generated by the system, what is the DG power that is generated by the system, what is the battery input power which is there. These are the various technical data which we'll be using. These are the various weather resources data which we have used. So we have average daily solar radiation available. We have hourly solar data. We have hourly wind speed data. We have hourly solar radiation data available. Then we have wind speed, that daily average wind speed graph has been shown. We have water availability on the basis of various requirement. What is the daily load which we have using? These are the example of the way system. We have a PV power, we have fuel cell for storage of the energy, we have diesel generator which will be generating the energy, we have load which have to be supplied, we have battery bank which we require, then we have voltage versus time, we have various operating. In some region we will be operating day region, we will be operating the photovoltaic panel. When the photovoltaic energy is not available, we will be using the battery, and if battery is not able to supply, we will be using the fuel cell, and if fuel cell is not able to supply, we will be running the diesel generator, and then again with the help of this DG we will be charging the battery, and then we will be having battery power which will be supplying the load. So these are the various curves. Now the other terms which we are using is weather forecasting, because we have hybrid energy system which complete efficiency will be depending on these weather parameters. So on the basis of weather parameters, we require to forecast the solar radiation and wind speed data, and these forecasted will be used for these algorithms, and then with the help of these algorithm we have compared what is the effect of the forecasted data. So we have these algorithms, we have this neural network for wind speed forecasting, then we have this solar radiation data for forecasting with the help of neural network. And these are the effect of the forecasted data which we have analyzed as compared to the optimal size result which we have used for the BBO algorithm. So this is the optimal size result which we have used for the BBO algorithm, and then we have analyzed that what is the effect of measured data versus forecasted data on this performance of this optimized hybrid energy system. So first is measured data we have used. So the PV power which is generated is 9% of the total. Wind turbine generator is 63% of the total. We have 0.724 watt hour per year is the unmet load. Diesel requirement is 124 and the loss of load probability is 0.02. When we have used solar forecasted data and wind speed measured data, the requirement of diesel you can easily see that reduced. But when we have used the solar radiation forecasted and wind speed forecasted data, you can easily see that the percentage of the wind power and wind photovoltaic power has increased. Unmet load has been decreased. The diesel requirement has also significantly reduced, and the loss of load probability has also reduced. These are the various effects of the curve, because when we have used the wind speed data for year 2010, it will be green line which is showing, and when we have used the forecasted data of wind speed 2011, the graph is shown by the blue line. So you can see that there is a significant difference in the data which we will be using if we are using the previous year data as compared to the forecasted data. So these are the effect. So we are able to design. So there are lot of opportunities which are available in this system. So we can have collect enough wind speed data and solar radiation data, and it can be used for all over India on the basis of location. Wind speed and solar radiation data incorporated, because there are variation, so sensitivity analysis can be done. Economical analysis can also be done with the help of various different parameters of PV component, wind turbine components, because individual manufacturer have individual characteristic, so that analysis can also be done. There is very less analysis which is done on the forecasted data use of the hybrid energy system optimization, that can also be done, and majority of the work is also required for the hardware implementation of this hybrid energy system. So this is brief about hybrid energy system optimization and the effect of forecasted data on the hybrid energy system optimization.
On the behalf of the Airbag Education Institute, Agra, this is the e-memento from our side. Please accept it, sir.
Thank you, sir.
Thank you very much, sir. Thank you very much for being with us.
Thank you.